Welcome, everybody. Today we're going to be talking about best practices for streaming connected car data into or with MQTT and Kafka. As mentioned, my name is Florian Raschbichler. My role is Head of Support for HiveMQ. A few words about HiveMQ. It's an 8-year-old startup. We are based in the Munich area, currently at 33 employees, and we have some more than 130 customers that are already using our products in production IoT applications, and I have proudly supported all of those customers in their journey from proof of concept to production now. In the past, we have been awarded with a number of awards for our growth in the IoT industry. You can check our website if you're interested in more details here. Today's agenda, we will be looking at various use cases where the technology we are showing will be useful. We'll take an in-depth look in the architecture we are precisely using. I will then show a live demo of the use case that we picked out, and we will be talking about best practices and next steps for you to also start testing this out or even getting a use case going. So in today's world, when it comes to automotive and car manufacturers, really the connected car is more and more important also for the customer. Actually, this is not on this slide, but there was a survey done by Deloitte in 2019, and I think more than 60% of customers in the age group from 20 to 40 said that connected car services might be an important metric for them to even switch the manufacturer. Typical use cases are really connected car infrastructure. A very prominent use case there is improved navigation, premium navigation services, where you combine the traffic light data with your current location and traffic data, and can provide your customers a alternative route that will route them through mostly green lights. Another very important use case, and this is the one we're going to be looking at today, is real-time analytics, which can be used for example, for predictive maintenance or maybe fleet optimizations. Continuous services and sales, which you can also think of as function on demand, is also an ever-growing reality in the connected car industry, allowing customers to put on subscription for special services on the go. And specifically using open standards like MQTT and Kafka makes it relatively easy to also find integration with partners like car shops or gas stations. And of course, as always in the emerging technologies, there will be many more use cases to come in the not so distant future. So now let's have a look at the architecture that we are using. So as you can see here, everything we're showing today is run on Kubernetes. This is done most importantly because we want to really show cloud nativeness and demonstrate that this can be hosted anywhere. It is vendor independent. Anywhere you can run a Kubernetes cluster, you can run this. The demo will be shown on the Azure AKS Kubernetes service, but any other Kubernetes will also work. As the central component, we have the HiveMQ Broker, where our test clients simulating 100,000 cars will be connecting to the broker and sending data. And then the HiveMQ Kafka extension is connected to a Kafka cluster run on the Confluent platform. We are happy to say that Confluent are a technical partner of ours, and we work closely with them together in developing our Kafka offerings as well. And really from that Kafka cluster, you can utilize all the advantages that Kafka bring in terms of streaming the data. So for example, you could use a KSQL to first process the data, and then this part of the use case, of course, we cannot show in this demo. This would be too much, but from there, so typically, for example, you could put the data directly streaming into a TensorFlow I/O application and do really streaming machine learning on the go. And then whenever you detect, for example, an anomaly, you can then bidirectionally, of course, you could send back data to the car. But this will make also a little bit more sense, I think, when we look at the actual live demo. We are using the MQTT protocol in our architecture to get the data from the cars. MQTT is an open standard publish subscribe messaging protocol that is built upon TCP/IP. It is really optimized for high throughput, high scale deployments. So hundreds of thousands, tens of millions of devices can be connected to a single broker cluster. And there is a wide variety of broker as well as client implementations out there, many of them as well open source. And this protocol was built to monitor oil pipelines over satellite initially. So it comes with a rich feature set that can really work with bad networking and connectivity conditions, and can also be implemented on very lightweight devices as well. Although for cars, this is not really necessary. We are using best-in-class technology here. This includes the HiveMQ Broker, a high availability clustered HiveMQ Broker, really built for reliability and scalability. Like I said, tens of millions of concurrent connections is already a reality. HiveMQ is built to integrate with your specific security needs, and with the control center that I will be showing shortly, you also get built-in observability into your MQTT deployment. And of course, HiveMQ supports the newest MQTT standard, MQTT 5. At HiveMQ, we really focus on being a cloud-native component, cloud-native infrastructure component, which is very scalable and flexible. You can do agile deployments. Maybe some of you already heard of the magic words lift and shift. So if you want to be moving your deployments, maybe from on-premise to public cloud or between public cloud vendors, HiveMQ's design makes this really easy. And you can absolutely avoid vendor lock-in when it comes to your infrastructure hosting. Looking at MQTT, we have a number of pros, of course. It's a lightweight protocol. Support comes across all programming languages. It is really built to resist high latency and low connectivity network conditions. Scalability and availability is very high when using a clustered high-performance broker like HiveMQ. It is an ISO standard and also standardized by the OASIS Technical Committee, and has now been shown for the last 4 years to be the most popular IoT protocol based on the Eclipse Developer Survey. Also, of course, it comes with a few disadvantages. It's a purely publish subscribe messaging protocol. You cannot do streaming or stream processing with MQTT, and you can also not reprocess events. Now, looking at Kafka, which is also growing and growing in popularity when it comes to stream processing protocols, it provides your organization a globally scaling platform to process events from producers and consumers. It gives you the ability to instantaneously access all your data in real time. You get the chance to have a single system of record where all your event data passes through, and you can really run all kinds of processing operations like real-time queries already on the data. It's really at our colleagues from Kafka like to call it the central nervous system of events in your operations. Of course, Kafka also has a lot of advantages, such as stream processing on top of being a PubSub protocol. It can be built for really high throughput and large scale. Also, typically comes in a clustered high availability approach. The messages can be stored long term and buffered there. You can even reprocess events, and it's also built to integrate really well with enterprises. From an IoT perspective, it is not ideal because it is not built for tens or even hundreds of thousands of connections. You need a stable, solid networking infrastructure. Stay connected to Kafka. There are no IoT specific features like, for example, the keep alive mechanism or the last will and testament mechanism that MQTT brings. Now, this brings us to one conclusion, and that is that if you combine the de facto standards for processing data and the de facto standards for IoT messaging, you get the de facto standard for processing IoT data, and MQTT and Kafka are a match made in heaven. All right, let's go to the live demo portion of this webinar. Quick overview again of what we are using here. So we are using this TensorFlow model portion of the demo will not be shown here. Like I said, we have the HiveMQ device simulator simulating our clients. I just recognized that the slide is not quite up to date. So it says here that the HiveMQ operator is not public yet. This is no longer true. The HiveMQ operator is actually publicly available and will help you really easily operate your HiveMQ cluster on any Kubernetes. Similarly, we are using the Confluent operator to run our Confluent platform with the Kafka cluster. And yeah, we're using Kubernetes ingresses, so I can connect to our dashboards from my laptop right now. Now here we have the HiveMQ dashboard where we can see we have very close to 100,000 clients connected. They are publishing roughly 5,000 messages per second, which is a realistic value when it comes to connected cars. Here you can really see that the HiveMQ Control Center already gives you many insights. We have a 5-node HiveMQ cluster. Of course, you can arbitrarily scale this cluster horizontally by adding more nodes, or vertically by also using more powerful nodes. So these are rather small nodes with 4 CPU cores and 3.7 gigabytes of Java heap. And this is an 8 gigabyte RAM machine we are using here. The cool thing here is on this dashboard, we connect it to this specific node, but we get the data for all nodes. And then we also get it split across the nodes. What we can do here, we can take a snapshot, and I just realized I should have taken the snapshot before the demo started, but that's okay. You can see it takes only really a few seconds for 100,000 clients. If you're talking about millions of clients, of course, this could also take a few minutes, and then we get actual insights onto the connected clients on the spot. And of course, our clients here are simulated electrical vehicles, just with a number. And if we click at this, we could see this is already an MQTT 5 version client, and we can get into all sorts of MQTT relevant information here. Also, when is it connected? If this client had a subscription, we would see this here. For the purposes of this demonstration, our clients are really just producers of data, so they do not have a subscription. They simply publish speaking in MQTT terms. We have a few other tabs that are not relevant though to this demonstration, but what's really cool is that we also have a Kafka dashboard here that shows us the current health of our Kafka deployment and how our Kafka extension is doing. Also here, Kafka, we have a relatively small deployment. Of course, for 5,000 messages per second, this is more than enough. We have 3 Kafka brokers. And as you can see here, all the incoming messages are also written to Kafka. Down here, we would see that also, of course, the direction from Kafka to Kafka to HiveMQ, and then from HiveMQ to your MQTT clients would also be possible. Now, let's take a look at the Confluent dashboard. And we can see here we have one topic, which is sensor data. Now, we can check here the messages that are coming in on the live. And here you can see what kind of data we are talking about, and we get some speed and some acceleration information, what control unit we're sending from. And of course, this is all simulated data. We have an Afro message simulator that we built for our device simulator to go with this, which could be really useful for actually testing, for example, a machine learning pipeline. And yeah, we have all these values, and if we collect enough of those, of course, we can use it to train a machine learning model and then apply that model and really could recognize if something is not going as intended and then react. And for example, if the temperature of our engine gets too high, maybe get a throttling message across to our vehicle so that it knows it needs to slow down. Maybe here also worth showing, this is all again running here on the Azure Kubernetes service. And for example, here we can see that we have 5 HiveMQ pods running. And I want to stress this. This is not native to Azure in this case. This is just one example. Any Kubernetes deployment would work with this specific demo. But also, of course, everything that we're showing would work outside of Kubernetes on a on-premise direct deployment on virtual machines. But we chose this approach because it's really easily portable and also very easy for you to copy, so to speak. And maybe I want to show one more thing. Here we have our HiveMQ Kubernetes deployment automatically comes with this also Grafana monitoring dashboard, where you really get lots and lots of insights, and your operations team is going to love this. Now, I mentioned we built this, and we built this together with our colleagues from Confluent, specifically Kai Vena, and this part I want to put a huge shout out to Kai, who initially built this demo with us together and is kind enough to even host this exact demo on his GitHub profile. So if you go to the link here, you can actually download this repository and test this out on your own. You can get it up and running in as little time as 30 minutes. All that's missing, of course, would be a hosted Kubernetes cluster. Once again, big thanks to our colleagues from Confluent and to Kai Vena in specific. Okay, now let's talk about the best practices that, again, we came up with those in collaboration with our Confluent colleagues, and when it comes to streaming connected car or any data from IoT devices. Now, when you get started, of course, it makes sense to start small, but if you start small in the right way, you are already prepared for scalability from the get-go. So really use cloud-native products that are scalable. As we showed in this demo, the Confluent platform as well as the HiveMQ MQTT platform are ideal candidates for that. Now, if you get started, and you will notice if you look at this, there is multiple options to connect MQTT and Kafka. Certainly, the HiveMQ Kafka extension is not the only one. There's also a Confluent MQTT connector, or you could even build a custom integration. We will shortly look about the advantages and disadvantages of different solutions here. And also very important, talking in the automotive space, this is already an enterprise business, right? So plan for your enterprise readiness. So what about security? What about monitoring? Like I showed you, for example, both HiveMQ as well as the Confluent platform already come with built-in dashboards that can be used, and also offer the opportunity to integrate really well into technologies like Grafana. And also, I would really look into bidirectional communication methods. Again, in this quick demo, we were simply collecting the MQTT data to Kafka, but with the stack that we are using, it would also be absolutely possible to send the data back to the cars. And the HiveMQ Kafka extension can really help you here, multicasting messages that come from Kafka to MQTT topics, or the other way around, really collecting. So what we did, each of the 100,000 cars that we saw there, they had their own individual topic that they published data on, but we collected it into one single Kafka topic. Now, the HiveMQ platform is what we chose, of course, for the MQTT part. It is really built for integrating with enterprise systems, and it also runs the cloud natively. Other options for the part of connecting your MQTT with Kafka. So we have Kafka MQTT Connect, and we have the Confluent MQTT Broker. So for example, the Confluent MQTT proxy has a big advantage that you don't even need an MQTT broker, and you can directly connect your MQTT devices to the Confluent platform. Disadvantages is that it really only supports a subset of MQTT 3 and MQTT 5 features not at all, and you can also, it only is one directional, so you cannot send data from Kafka to your devices. The Kafka MQTT Connect integrates with the MQTT protocol. It's well suited if your Kafka cluster is really outside of your MQTT broker. It has an MQTT 3 support, and some simple basic transformations are also possible. And it does already support bidirectional messaging through the MQTT broker. Now, if you're looking at the HiveMQ Enterprise extension for Kafka, which is the full official name, we have bidirectional messaging between IoT devices and the Kafka. It is really built to scale for up to millions of IoT devices and hundreds of thousands of messages per second throughput. We support the entire MQTT 5 feature set, including all optional features. For those here a little bit more familiar with MQTT and MQTT 5, very importantly, this also supports the user properties feature, which is a header feature that MQTT 5 brings, which really integrates well, of course, with Kafka headers as well. And it's really built for reliable connectivity, and this goes so far as to we have also bidirectional buffering. So if your Kafka for some reason would not be available at time, Kafka would buffer in that direction. And also if the IoT device is offline, HiveMQ will make sure that the message coming from Kafka will be delivered. So we have end-to-end really messaging guarantees with the HiveMQ Kafka extension. And yeah, it seamlessly integrates with the Confluent platform and even with the Confluent cloud. So we also integrate with the Confluent schema registry. You can do role-based access control. I want to say here, of course, so you do not have to use the Confluent platform with the HiveMQ Enterprise extension for Kafka. Any Kafka service or broker can be connected here. So, for example, you could use the MKS from Amazon, or you can use your self-hosted Kafka. And you can also connect more than a single Kafka cluster to your MQTT broker. Here's a quick demonstration also how it works. So we do it really in both directions. And very important to note also is in both directions. So when I'm talking about getting the MQTT message and writing it to Kafka, as well as getting the Kafka message and sending it to the IoT device, you also have very extensive customization options on the messaging. So for example, like I mentioned before, if you wanted to take the user property of an MQTT publish and use that to set it as the header or another attribute of a Kafka record, you can very easily do so. Or sometimes maybe the messaging format might be different. For example, what I see a lot in practice is that the protobuf is used as the format, and maybe you want to read some specific protobuf header and use it as, for example, the Kafka key, but then really only persist the payload of the protobuf and get rid of the headers before writing them to Kafka. Is also something that you could do here. And yeah, here also maybe this trying to show a little bit that the multicasting and the spreading of topics. So you have the MQTT topic, devices, and then ID1 and data, and it will really write to just one device's data topic. And on the way back, Kafka is sending on the devices data topic, but HiveMQ reads a specific part of the Kafka record and knows, okay, this has to be going to the devices ID2 data topic, and will send it that way. That really helps you bridge the gap between the disadvantage from Kafka of not being able to handle an arbitrary amount of topics and not being able to have an arbitrary amount of devices connected to it. Whereas MQTT is really built for dynamically scaling up to literally hundreds of millions of topics can be used on a single HiveMQ cluster. And this really helps bridge the gap here between the two of them. Now, if you get started, you should really start by making sure to choose the right tool from the get-go. I mean, yes, I've talked about lift and shift being easy with, or relatively easy with HiveMQ, but still, of course, try to make the best decision as soon as you can. Get yourself familiar with the advantages and disadvantages that you have on edge or on-premise or cloud deployments, and choose what's right for you. And whatever you choose, use the best tool for the job, which is the Confluent platform for event streaming, and really HiveMQ for the MQTT connectivity. We will show later that both also Confluent and HiveMQ have open source parts in their offering that can make it easier to get going. Now, when looking at your end-to-end data processing pipeline that we showed, it's really important to know that you should separate your concerns. So your devices, you have concerns like devices and the gateways and the integration, data streaming, and consumer apps, and you should really not put all of that into, let's say, a single data sink and figure it out afterwards. I've seen this approach before, just building a huge data lake and then afterwards figure out what to do with the data. It's really better to decouple your tasks, look at your source integrations, do the data processing as early as possible, like we showed in the architecture using a technology like KSQL. Is absolutely perfect for this. Know where to put your business logic. So, for example, it's possible to put it on the HiveMQ Broker, if that makes sense for some data streams. For other data streams, it might really make sense to process and then collect, process, pre-process the data, and then really at the end of the pipeline, put your business logic on top. Example, of course, would have been the machine learning pipeline that we talked about with the TensorFlow model that you apply at the very end of the data collection. And yeah, think about analytics and your think integration early. And really, if you try to build a system like this, just it's a good sign if you really know what concern and what use case you are solving with which specific part of your application and with which specific integration. Also, and this comes, it goes in the same direction, you could really use, or you should really use different data specifically for different use cases. And this, so for some data, it is absolutely sufficient or even useful to use databases. If you have just in a logging capacity, long-term storage for years and years, then something like a database and data lake might be absolutely what you want to be aiming for. Now, if you want to have searched and indexed data, then there's technologies for that. Something like Elasticsearch comes to mind. Other times you need real-time or near real-time capabilities for your data, then this is already where Kafka is really strong. Of course, streaming and request response type data does exist. Streaming again with Kafka, if you want to do request response with your data, then maybe good old HTTP also still can be very valid. TQRS or event sourcing is other types of data and structuring that you really should then find technologies. And yeah, machine learning, not sure if this came up, but if you're looking at machine learning, which is of course a very highly relevant buzzword for many years now, there's within a machine learning platform, typically you have different data structures and different technologies to use. So the Swiss Army knife of data events, unfortunately, does not exist. There is not one event to rule them all, to use another cliche. All right, now that we've gone over this specific use case and talked about best practices for you to integrate them, what are the next steps for you to get going? So this demo that we showed, again, I want to reiterate this. Kairina is kind enough to host this on his GitHub. It is open. Anybody can participate also as in committing to the project if you have improvements. And this demo also includes the entire pipeline that we saw. So this includes the TensorFlow training model and really the bidirectional data flow. So if you're looking into creating something like a predictive maintenance use case, this demo is really a good way to start. If you're wanting to try this out, and if you're wanting to try this out in a higher scalability, you will run into licensing problems with HiveMQ. But if you do so, please just reach out to us or to me directly. I will show my contact data later, and we are very happy on HiveMQ side to provide you with a evaluation license so you can test this out for yourself in a higher scalability. If you're talking about hundreds of devices, you can just start going already. Once again, I want to make this point twice. Really, if you're talking about HiveMQ as your MQTT platform and Kafka, this is an absolutely ideal match for making IoT data streamable. And yeah, we took a look at the trade-offs and the advantages of disadvantages of the MQTT protocol and the Kafka protocol. They really complement each other quite well. Now, looking at the technology shortly, once again, that we used for our MQTT part, we were using the HiveMQ platform. This slide shows most of our offerings, and if you can see the yellow parts, these are our commercial offerings. So you need a license to access those. Again, if you reach out to me, or if you reach out to our team in the contact form on our website, we will happily provide you the chance to evaluate the commercial offerings before you don't need to buy the cat in the bag, as we say in Germany. I'm not sure if that translates. And but also we have a very wide array of open source products, which we already have can use a HiveMQ broker that is a standalone broker, the HiveMQ Community Edition. You can find it on GitHub, and you can also write extensions and use our non-enterprise extensions with this Community Edition. We also have a Java MQTT client library that we built together with the BMW IT guys, which is built for really high scaling throughput. And we have a command line interface tool, which if you check it out, you will learn to love it because it's the best, in my opinion, development and testing tool out there for your MQTT applications. Now, similarly to our approach, also the Confluent Kafka approach comes with a portion of open source services and then enterprise services on top of that. So the dark black part, which is really the Kafka protocol itself, is free of charge. And then if you look into the more sophisticated offerings, like providing connectors to all kinds of services and technologies, the MQTT proxy that we talked about, REST proxy, the schema registry, really good stuff that really helps you increase the value of your Kafka setup. All of this comes with the Confluent platform and KSQL, like I showed, which is like the native pre-processing database that Confluent provides. And even on top of that, once you get into a state where your deployment becomes mission critical and you want to make sure that you're compliant with your IT security standards and you want to make your operations team happy, then you can, security plugins, a replicator, a control center that we showed, role-based access control, all of the good stuff is provided by our good friends from Confluent. And what you see here on the left side, this is true for HiveMQ as well as Confluent. We really, you get professional support, you get professional services, trainings, and really a partner network around the globe if you go with these offerings that can help you going. All right. Now, at the very beginning, I talked about us having 130 customers. You can actually access a full customer list on our homepage, but since this is an automotive-based webinar, I just really wanted to highlight some of our customers here. These, of course, as you can see, most of the German OEMs, at least, already go with HiveMQ. We have also many tier 1 suppliers. We cannot list all of the automotive customers that we have actually here because not all of them are happy to do so. Other than working with connected car and the automotive industry, we also help our customers to build new digital products like Liberty Global. You can find the case study on our homepage. Of course, everything about connectivity of devices is to improve the customer experience. Sometimes it can also help you be more efficient in your operations and insights. Or here you can take a look at the Daimler case study that shows this. And more so relevantly, we connect factories as well as devices and cars. And just wanted to also put out there that on top of the readily available cloud-native software that you can host in Kubernetes or anywhere else, HiveMQ also has a managed service, the HiveMQ Cloud, that comes with a pre-built integration to the Confluent Cloud. So if you want to get going with a use case like I demonstrated, but you don't care for hosting it yourself, you can always find a fully managed version of it as well. Okay, next steps. Once again, I want to point to Kai's GitHub repository where you can find the demo that I showed with a README file. It should be relatively easy to get going with in about 30 minutes. You can go to the HiveMQ blog and read a little bit about what MQTT and Kafka, how it really works together, and contact us or contact me personally if you have any feedback, if you have any question, if you want to evaluate HiveMQ yourself. Thank you.